Hello kids, in today's class we are going to start with the new chapter decimals. Okay, and we have learned decimals already in the previous class. So how we can represent a decimal as I am telling you here. So supposedly we want to see any decimal number. So 0.7 let's say is 1, 0.11 is 1, 0.23, 1.98, 79.06, so many numbers. All these are decimal numbers and this dot, it represents the decimal. Okay, so now if we see the place value chart, how we represent the decimals and the number around it. So first of all, we know we have ones, then we have tens, we have hundreds, thousand, 10,000 and so on, right? So all these are the place value. This is the place value chart and all these are the places which we can have in any number. Okay, so when we call decimals, what we have here is after ones we have decimal. Sorry, here we have a decimal. Okay, and to the right of the decimal, if we go to this side, we have tenths, TENTHS. Okay, this is tenths. Then we have hundredth, hundred, and we have thousands, thousands, 10,000 and so on. Okay, so this is how we represent a decimal number. So if we call this number, let's say we take example of this number 0.7, then we can say at the ones place we have zero. So there is nothing at ones place. This is the ones place. At ones place we have a digit 0. Then we have a decimal which is represented with a dot here, and then we have 7. So what is the place value of this 7? This 7 is at 10th place. Okay, so this is TENTHS, 10th place, and how we represent a 10th place is 1 by 10. Okay, like in the case of ones we have 1, in the case of tens we have 10, then we have 100, we have 1000, we have 10,000 and so on. Similarly, at the place of decimal it is represented with a dot. Okay, and then we have a tenth, 1 by 10, we have hundreds which is represented with 1 by 100, then thousands which is represented by 1 by 1000 and so on. Okay, 10,000s we'll have the more numbers. Okay, so here in this particular number 0.7, at ones place we have 0, then we have a decimal followed by the 10th place. So at the 10th place we have 7. So how we can write the 10th place here? This number can be represented by 7 by 10. Okay, because we have 7 at the 10th place, so we can write this as 7 by 10 here. Now let us take the another number 0.11. So when we take 0.11 here, we have at ones place again we have 0 here. At 10th place we have 1. At 100th place also, this is 1, 10th place, this is 100th place, we have 1 again, this is 100th place. Okay, and now how we are going to represent this number? This number we have 11. So after decimal we have 2 places here. So this is represented by the hundredths place. So we will write this as 11 by 100. Okay, similarly I am taking another example of 1.98 now. So in the case of 1.98, at ones place what we have is, at ones place we have 1 followed by a decimal, and then at this place 10th place we have 9, at 100th place we have 8. And how we can represent this number? If we remove this decimal, then we can write this number as 198 and this as a fraction divided by 100, because after decimal we have two places. So we will write 20, hundreds place. So this whole number is 198 divided by 100 as a fraction. These all are represented in a fraction form. Okay, this is the fraction form, and these all are the decimal form. These all are the decimal form. Okay, so I hope you have understood what we have learned about the decimals here, that in a place value chart we have ones, tens, hundred, thousand, 10,000 and so on. Similarly, in the case of a decimal number, after ones we have a decimal, and it is followed by tenths, hundreds, thousands and so on. And these tenths, hundreds and thousands, they are represented like this: 1 by 10 for tenths, 1 by hundreds for hundred, 1 by thousand for thousand and so on. So we will see after decimal how many places are given to us. That many zeros we will have in the denominator. Okay, one followed by those many zeros we'll have. Now let us take some another example. Let me take an example of thousands now. Okay, let me take 2.694. Right? So in this case, at ones place we have 2 followed by a decimal. Then we, after decimal, this is the tenths place, this is the hundredths place, and this 4 is at the thousandth place. Okay, and if we want to represent it in the form of a fraction, how we are going to do this? 2694. So when we are removing this decimal, in the case of fraction, it will be 1 followed by 1, 2, 3. After decimal, we have 3 digits. So 3 zeros. Why? Because 3 zeros represents the thousandth number. This means we have these at the thousandth place. So this is the fractional form of this decimal form number. Okay, same thing has been written over here, that how we represent the tenths: 1 by 10, 2 by 10, 3 by 10, 4 by 10 and so on. How we represent the hundreds, like we say 1 by 100. So in different things we have different numbers: 1 by 100, 2 by 100, 3 by 100, 4 by 100 and so on. All these are the fractional forms, and when we have to write these fractional forms to decimal forms, we will learn this going ahead in this chapter. Okay, and similarly we have learned the thousands place, which is represented by 1 by 1000, 2 by 1000 and so on. Okay, so this is the thing. These are the decimal representation of a number, and this is the fractional form, okay, or fractional representation of the number. Now what we have next here is examples of a mixed fraction as decimals. So supposedly we are given a number, but before that let us understand how normally we have to write the fractional form of a given, decimal form of a given fraction. Okay, so let us consider the first example where we have 17 by 10. So it means if we have 1 0 in the denominator, that means the decimal will come after one place starting from the right always. Okay, so just before 7 we have to put this decimal, so the number will become 1.7 here. Okay, I hope you understood what we have done. Since we have only 0 in the denominator, that means we have only tenths place, and we always have to start from the right to left we will go. So 1 0 means one place, so after one place we will write down the decimal. This is the decimal representation of this fractional number. Okay, now let us take more examples here. Now I am taking another example of, let's say we have 6 divided by 100. Okay, so now we have 6 divided by 100. That means the decimal will come after two places starting from the right one. So first of all, we have 6, we will write 6. But we do not have enough numbers in the numerator to cover it. So how we are going to write it? We are going to put 1 0 here. Just before 6, we are going to put 1 0. So now we have two digits for these two 0, and then we will write a decimal. Okay, so kids, always understand that if we have any such number, if we do not have anything just before the decimal, we can always write down 0, because 0 again means nothing here. Okay, so this is how we can represent this number. Now let us take more example. I'm taking 8.93. Okay, so how we can represent, sorry, okay, reverse we are doing here first. So let me take more examples of 16 point, sorry, 16,748 divided by 1000. Okay, so now what we have is, we have three zeros starting from the right, we are going to put the decimal. That means 748 are covering these three places. Then we are going to put this 748 and then the leftover part, that is 16. So the decimal part will become, this number will become 16.748 in the decimal form. Okay, let me take one more example now. I'm taking example of 17 point, sorry, again point, 17,168. Okay, and now in the denominator I am putting 100. So I'm putting 100, that means starting from the right, the decimal will come after two places from here, from the right. So 86 as is, and then 171 the remaining number. Okay, so here we have learned that how we have to represent any fractional number into any fraction into the decimal form. Okay, so now this is one thing. Other thing is that we have also learned that how we have to do the reverse of it, that we were given the decimal form and how we have to write the fractional form of this. And this is the reverse. We have done fractional form to the decimal form. Okay, these two things we have done now, kids. Now let us understand that how we have to write a mixed number. If we are given any mixed number, how we have to write that mixed number as a decimal. Okay, so let's say we are given a number here, 6 1 by 100. Okay, so in this case we have learned that we have two parts. This one is the whole number, so I can write this 6 as it is, and then in addition to it plus this fraction 1 by 100. So first of all, we know that whenever a mixed fraction is given to us, this is the whole number and this is the fraction. The combination, the addition of this give us the mixed fraction, right? And now again it is very easy. 6 will be as is, and this 1 by 100 we have, this can be represented as a decimal. How? 0, sorry, starting, we have two zeros in the denominator. Starting from the right, we will write down 1 here and then 1 0, because we do not have enough numbers to cover the another 0. So we are writing 0 1 and then a dot. Okay, so this is how we can write down 1 by 100. It is 0.01. And then what we have to do, just add these two. 6 plus 0.01 will give us 6.01. Now kids, addition of the whole number and a decimal number we have learned already in the grade 5, but again I'm telling you here, if we have any whole number and we have to add it to a decimal number, so first of all we can always write down that whole number as 6.0, because point, after point if we have 0 0, it doesn't have any value. Okay, so we can write this 6 as 6.00. To this we are adding this 0.01, so 0.01, we will get 1 plus 0 as 1, this as 0, decimal, and 6 as this. So 6.01 is the answer after adding this. Okay, so similarly we may have more numbers. So let's say let's see the another number which we have here. I am just erasing this part only. And next we have, in the given example, we have 1829 by 1000. So how we can represent? Let us first split the whole number and fraction differently. So we have these two things. This is the whole number, this is the fractional part. And next what we have to do is, we'll keep the whole number as is 18 and now represent this 29 in the form of fraction. These two zeros will cover 29 and then we have one more zero, so we will add one zero here. So we'll have this as 0.029, and when we are adding this 18.000, we have to write something like this, okay, because this is a whole number. To this we are adding this 0 to 9, so when we are adding this we will get 18.029 as the answer. Okay, so this is how we have to do this question. Okay, now kids, next what we have here is like and unlike fractions, like and unlike decimals. So kids, like how we have done the like and unlike fractions, we also have a concept of like and unlike decimals, and this is very easy. So I'm writing here like, sorry, wait, yeah, like decimals. So these are the decimals which are having the same number of decimal places. Okay, example I am saying, if I have 7.42, let's say, and 1.06, so in both of these two decimal numbers, after decimals we have two decimal places. Yeah, we have 10th place and 100th place here. Also here we have a 10th place and a 100th place. So in both of these two fractions, the number of places after the decimals are same, so they are the like decimals. So what are like decimals? They are the decimal numbers having same number of decimal places. Okay, and here we are considered only about the decimal places and not before that. What I mean is, if I have a number 112 plus 756, and if I have another number as 6.234, okay, we are only going to compare the numbers after the decimal, the number of places after the decimals. Here in both the cases, the number of places after the decimals are 3. Both of them, they have thousandth place. We have the number till the thousandth place. So that means they are the like decimals. We are not considered about the numbers which are present before the decimals. Okay, so like decimals are the decimal numbers which are having the same number of decimal places. Okay, let me also take another example. Let us say we have a number 1.72 and then we have another number here which is 23 point, sorry, yeah, wait, which we have 23.1. Okay, so these two are the numbers here. Are they like decimals? So if we see here in the first number we have two places after decimals, whereas in the other one we have only one place after decimals. Okay, so since the number of places after the decimals are not same, they are not like decimals. So what do we call them? They are called as unlike decimals. Okay, so what are unlike decimals? They are the numbers which are not having same number of decimal places. Okay, decimal places. So this is one example of unlike decimals. Okay, let us take another example now. So let me see if we have a number 11.023 as one number. Another number I'm taking 17.11. So here also the number of places after decimals are not equal, so they are example of unlike decimals. Okay, because the number of places after decimals are not equal. Okay, so I hope that you have understood like and unlike decimals now. Now let us move further and see that if we are taking a number, let's say I have a number 0.7, then that 0.7 number can be represented as 7 by 10, right? We can write this as 7 by 10. Also, after decimal point, if we do not have any number followed by it, we can put any number of zeros. Okay, so what I mean to say here is that here in this particular case, after decimal, we have only one digit at 10th place, and that is 7. Okay, and we can represent it in the form of fraction of 7 by 10, right? Now I can also write this 0.7 as 0.70. So when we are trying to write it in the form of a fraction, it will become 70 divided by 100. Why? Because now I have two decimal places. But when we are going to solve it, if you are just going to solve it, then this zero will cancel, and we will ultimately get this only. Okay, so that means if I write down 0.7 or 0.70, or if I write down 0.700, or if I write down 0.70000, all these are same. The only criteria we have here is that 7 is not followed by any other digit. Okay, what does that mean is that I cannot put, if I have a number 0.76, I cannot put any 0 in between 7 and 6. That will be incorrect. What I can do is I can write down the 0 after a number after a decimal, in a decimal number after the last number only. It should not be followed by any other non-zero number. Okay, so let's see here. 0.700, this can be written as 700 divided by 1, 2, 3. 3 places, because we have decimal after 3 places. And also here we can write down 7, 1, 2, 3, 4. 1, 2, 3, 4. And in the denominator, this is 1, 2, 3, 4 and 5. So 1, 2, 3, 4, 5. Right? If you try to solve it, everywhere you are going to get 7 by 10 only. Okay, so that means we can write down 0.7 or any number. If there is no, we can write down, we can add up any number of zeros in the after the last digit in a decimal number. I can write down 0.9 as 0.90, 0.900, etc. I can write down 1.61 as 1.610, 1.6100, 1.61000, and so on. That means we can write down any number of zeros after the last decimal number. That is not going to change its value. Okay, so this is done. And now let us see what is written here in the question. Let us go through these solved examples first. And then in the first one, what we have to do is we have to convert certain decimal numbers into like decimals. So what is given to us are unlike decimals, and we have to learn that how we have to convert them into the like decimals. So I'm writing here, convert unlike decimals to like decimals. Okay, converting unlike decimals to like decimals. So how we have to do it? Let's see. What is given to us here is 5.3, 7.19, 0.376 and 84. These are the numbers which are given to us. Since we have to convert them into like decimals, that means the number of the decimal places after the decimal should be same. Okay, so if you see here, kids, here we have only 10th place, right? Here we have only 10th place, that is one digit. Here we have two digits, here we have three digits, and here we have no digits. Okay, so let us first try to write these numbers. We have 5.3 here, and what we need is what we want to do is we want to convert them into like decimals, that all of them should have the same decimal places. So here in all the given numbers, 0.376 is the number which is having the highest number of decimal places. Okay, it has 3 decimal places. So what we are required to do is we have to convert all the other unlike decimals to 3 places of decimals, so that they should become like. Okay, so how we can write this 5.3 as, for 3 decimal places is 5.3, then we can add 2 zeros to it, because just before this question we have learned that if we add 0 after the last number, it is not going to change its value. Okay, so the value of 5.3 and 5.300 is same, but it is having 3 decimal places now. Okay, second one we have 7.19. So to this, what we have to add, we have 2 decimal place, we have to add 1 0 only, because after adding 1 0 only, we will have 3 decimal places. Okay, and then 0.376 will be as is, there will be no changes to it. Why? Because it is the one which is having the maximum number of decimal places, and we are changing all the others to make equal to this decimal number. Okay, the last one we have 84. This is a whole number, and we know that if we want to convert it into the decimal, we will put a decimal here and then 3 zeros. Okay, so what we have done here, we have converted all the unlike decimal to the like decimals. And for that, what we have done, first of all, we have identified that what is the number which is having the highest number of decimal places, and we saw it is this number 0.376, which is having 3 decimal places. And then what we have done next, we have converted all the numbers here to 3 decimal places by adding 0 in their last. How many zeros? That depend upon the number which we are taking. Like in the case of 5.3, we have only one place, we had to add 2 places, which we have done. And then in the other cases, we have added them accordingly. Okay, so I hope you have understood this, kids. Next, what we have is arrange the digits of this number. We are given a number here, 269.374. We have to arrange them in a place value chart, which we have learnt already. So let's do this fast. 9 is at 1's place, 6 is at 10's place, 2 is at 100 place. Then this is a decimal point. Then 3 is at 10th place, 7 is at 100th place, and 4 is at 1000th place, right? This is how we have to do it. And now if we wanted to write this in the form of zeros, what we'll have is 2 is at 100th place, so this is 200, plus 6 is at 10th place, it is 60, 9 is at 1 place, so 9 will be multiplied with 1 only, 9. And then 3 is at 10th place, 3 by 10, 7 is at 100th place, and the last one is 4, which is at 1000th place. Yeah, easy. So this is how we have to write it in the form of a place value chart. Next what we have is comparing the decimals, where we have to compare the decimals. So kids, understand this. I'm writing here comparing decimals first. Whenever we have to compare the decimals, first of all, we have to, first rule is always compare the whole part of it. Okay, whole part of it, whole part of decimal. The one with the bigger whole number is bigger. What does that mean? I have 7.432. I have 16.432. If we have to compare these two, First, we are going to compare the whole part. We know 16 is greater than 7. So this means this number will be greater. So same thing we have written here. First of all, we have to compare the whole part of it. Now, if whole part is same, then compare tenths part first. Now, let's say we have 7.432 and then we have 7.632. We have compared the whole number, it is same. Now we are going to compare the number at tenths place. Here we have 4, here we have 6, and we know 6 is greater. So this number would be greater. Okay. Third scenario, if both whole part, or you can say whole number and tenths place numbers are same. Move to next comparison. That means compare hundredths place numbers. Okay, so what does that mean? That means now if I have a number, say 15.236, and the other number I have 15.289, in this case whole number is same, tenth place is same, so we are going to compare the hundredth place. So here we know 2.898 is greater, so this number will be bigger, and so on. So this is how we are going to compare it. Okay, now using this, we have a question where we have to arrange the numbers in the ascending order. See, here we have 4.83, 6.07, 0.9, 0.465 and 7.4 given to us. Okay, let me just write down these numbers here. We have 4.83, we have 6.07, we have 0.9, 0.465 and 7.4. So since we have to arrange the number in ascending order, that means from smallest to biggest number. So first of all, we have to see the number which is having the smallest whole part. So we have 0.9 and 0.4. Both of them, they have 0 in the whole part. So if the number at the 0th place is at the whole number is same, then we will move to 10th place. So at the 10th place, we have 9 and 4, and we know 4 is smaller than 9. So the first or the smallest number in the given series is 4.65 followed by 0.9. Okay, these two we have written. Now what is the next largest number? We have to see the whole part first. We have 4, 6 and 7. So this is straight away we can write. We can write 4.83, 6.07 and then 7.4. So this is how we have to arrange the numbers, the decimal numbers in the ascending order. Okay, so with this, kids, we are done with the concepts and we are going to pick up the exercise in the next class. So what we have learned today is how we have to write the decimal number, how we have to convert a decimal number to fraction form, or if a fraction is given to us, how we have to write it in the decimal form, what is the place value chart of a decimal number, right? And how we can convert what are like decimals and unlike decimal numbers, and how we can convert unlike decimals to like decimals. Okay, and also we have learned that how we can compare the, what are the rules to compare the decimal numbers, how we can write them in ascending order. Okay, so I want you all to go through these concepts and do the examples so that we can pick the exercise in the next class. Okay, so I will see you all in the next class, and if you face any confusion over anywhere, you can always email me. Thank you.